Hey everyone, welcome back. Today we're diving into one of the most important pieces of OSPF, neighbor relationships, how they form, why they break, and how to fix them. By the end of this video, you'll be able to take two routers, configure OSPF, watch every adjacency state happen live, and troubleshoot common issues like MTU and timer mismatches. All you need to be that OSPF guru that you need to be. Let's jump in and take a look at the topology we're going to use to lab this. Here's the simple lab, a point-to-point link between R1 and R2. It's a multi-vendor setup, so we're going to see how to enable OSPF on an iOS XE device and a Juniper MX device. This topology is perfect for demonstrating the entire OSPF process. Let's start simple. Just enable OSPF, add the connected interfaces and some loopbacks into Area 0. We are also going to configure these as point-to-point interfaces. Since we don't need to elect a DR or a BDR on this link, we can just set this up as a point-to-point link. Let's get into configuring R1. All right, so we're going to enable OSPF. I'm going to go into global configuration mode, router OSPF, process ID is 1, and how to enable iOS XE for OSPF. It's with the network command. But first, we need to add the router ID. Now this will get chosen automatically, but I like to hard set this to whatever loopback 0 is, because you pretty much know what router it is by that IP address, and you don't leave it to OSPF to pick. Now, to configure interfaces in OSPF, you use the network command. So we're going to do network. We're going to do the address of the gigabit 1 interface. And what you're going to notice is when I configure it, I'm not going to use the standard subnet mask. I'm going to use the inverse mask, which essentially it's just taking the network mask, it's taking the actual subnet mask and just flipping it to the inverse. So a /30 would be 0.0.0.3. And I want to add this into Area 0. And I want to do the same thing for the two loopback interfaces that I have. So it's going to be network quad 1s, the inverse mask or the wildcard mask for a /32 is all zeros. I'm going to put that in Area 0 as well. And network 11, 11, 11, 11, same thing, into Area 0. Now, since I want to make this a point-to-point link, under the interface, I have to add that configuration. So under interface GI1, we're going to do IP OSPF network point-to-point. If you're curious as to what other options are under that, broadcast for a Ethernet link, point-to-multipoint and non-broadcast are kind of used in old school frame relay. You may want to use point-to-multipoint on a DMVPN, but that's really where those would exist. So let's exit out of this and let's configure the Juniper. So Juniper is going to be a little bit different. We're going to go into configure mode, and here let's set the router ID. So set routing options, router ID 22222, and now we're going to set protocols OSPF area. Now Juniper does things a little bit differently than Cisco. Now in Cisco, instead of just specifying the area with just a regular integer, you can also specify it in a dotted decimal format, kind of like you would a subnet mask. Juniper, you could only set the area ID in the dotted decimal format. Actually, can you do it the other way? Let's see. We'll learn something together. You can add that area any which way. In Juniper, I like doing it with the dotted decimal because it just makes it easier. We're going to add interface GE 000, and we're going to hit enter. Now, when you do things in Juniper, whereas in Cisco, as soon as you put the command in, the command is active. Juniper, you need to commit it. So we're going to do a few more things. we're going to add interface loopback 0 into area 0. And then what we're also going to do is we're going to make interface GE000 a point-to-point interface, which we would do that with this interface type P2P. Now we're going to commit this. That's all good. If we exit out of this and we show show OSPF overview, we'll see that it's actually configured. We don't see anything about this being a ASBR or an area border router. That's coming in a previous video, and he's only configured in one area. If we do show OSPF neighbor, we'll see there's no neighbors because the adjacency hasn't happened yet. So since we have this link this link disabled, we're going to do two things. One, we're going to look at Wireshark. So we have Wireshark running with a filter for OSPF so we can watch what the packets look like when they come in. And once I re-enable this interface, we're going to come to R1 and we're going to do show IP OSPF neighbor like our life depends on it, so we can try to see all the neighbor states. So let's get that. We're going to do show IP OSPF neighbor, get that ready. We're going to click the link and we're going to resume it. It's going to take a minute for the interface to come up, but no, R1 froze. Of course it did. All right, good. All right, so we see he's in EXSTART and he's in full. So we missed a few stages in this, but luckily for us, we have it here. So we're gonna stop this packet capture for now, and I'm gonna explain some of the stuff that's in here, but I'm also going to explain what the router states are that we missed. So what you'll notice is you'll see the state that the neighbor is in, and then you'll also see that there's a dash next to here. This dash would be used if we're on a broadcast network. It would tell you if the neighbor is the designated router or the DR, the backup designated router, the BDR, or if it's a druther, a DR other, which means it's just a router that's listening on the multi-access network that isn't a DR or a BDR, which is responsible for originating the LSAs in the event of being in a multi-access network. So what you'll see is this state. This state can be one of 7 different states. So you have down, where no neighbors have been seen yet. You have INIT, where it's I hear you, but you don't hear me. Two-way, where, hey, we can see each other. Then we start getting into some cool stuff. So we get into EXSTART, where that is going to determine who's in charge. So who's the DR and who's the BDR, if it was a multi-access network. Exchange is comparing what we know about the network currently, what my LS database looks like versus what your link state database looks like. Loading, where we're sending the missing details to each other. And then full, which the databases match. We're all good. Now, if we look at it in the packet capture, right? So we have let's open OSPF so we can see what's in here. Let's make this guy a smidge bigger. And let's see if I can zoom in. There we go. Let's zoom in 2 more times. And 1 more time. Awesome. So we see we have a hello packet that's going to the all OSPF routers multicast address of 224.0.0.5. It's like, hey, the 10.12.2 is sending out a hello packet for anyone who's listening on this network. Then you have your database description packet right after that. So it's R1 sourcing to R2. And what this is saying, it's like, hey, this is everything I know about the network, right? So it's telling you what the database description is, what OSPF options it supports, who's the link state. Like, this is just all information about what this particular router has in its database. And then R2 does the same thing. It's like, yep, here's what I know, let me know if you need anything. And then we see router 2 is sending a link state request where it's like, hey, I'm missing this LSA, send it to me. So it's saying it's missing the 1.1.1.1. So pretty much everything from this router. And then we see R1 is doing the same thing to R2 after R2 sent it to the all OSPF routers multicast address. Then we have our LS updates where it's like, okay, I see what you need. Here's what you're missing. Let me send this to you. So this is R1 sending R2 its entire LS database, which you can see it's loopback 0, loopback 1, and then the actual interface that's added into OSPF. And then router 2 does the same thing back. So it's like, yep, we're on this connected point-to-point link. You need to have that too. And here's my interface as well. Then a LS acknowledge is perfect. We've received it. Everything is in sync. We are good to go. So now we have an up OSPF adjacency. We can actually look at the routing tables on both of them. So if we do show IP route OSPF, on the Cisco device, we'll see we have a inter-area route to 2.2.2.2. We can ping 2222, and we can source it from loopback 0. We should be able to ping it perfectly. If we go to router 2 and do the same thing, if we do show route protocol OSPF, as you can see, there's some nuances to all this. We have some more intra-area routes. So it's inside of the same OSPF network, and we can do the same thing from here. So if we wanted to ping 11.11.11.11, and we wanted to source it, and we wanted to source from 2222, we can ping that too, and we can see that that's going through perfectly. Awesome. We can take it a step further if you did want to see the database, which I'm going to go in the next video in the multi-area OSPF and kind of break down the database a little bit more. We see we only have LSA ones. We only have router link states, right? And the same thing would hold true on router 2. So if we do show OSPF database, we only see that we have everything that's a router, so an LSA type 1. This is all perfect. So now let's break some things and let's look at some common OSPF issues. The first one is the dreaded MTU mismatch. Neighbors will not form even if the MTU is off by 1 byte. Let's change this on router 1, reset the adjacency, and see what it gets stuck in. So go to router 1, interface gig 1, it's IP MTU. We could theoretically lower it by 1 to make it 1499, but we're going to make it 1420. And then we're going to clear IP OSPF neighbor. So the OSPF process has been cleared. We'll see the neighbor's detached. He's down and he doesn't come back up. If we look at the neighbor, we're stuck in EXSTART. And being stuck in EXSTART, let's see if we remember, we're trying to figure out who's in charge, who's the master, and who's the slave. So we can see each other, but we can't exchange anything because our MTUs don't match. We can look into detail, and all it's saying is that it's stuck in EXSTART. And even if you were looking at a packet capture, all you would see is it's trying to just at anything, just trying to make the connection. So all you'll see is it's just trying to keep sending the database description, and it can't send the database description because of the MTU mismatch. And you'll see some hellos come through, like making sure, like, hey, any OSPF speakers on here? And in here, if you actually look at some of this, right, you know, it's this seeing this where it's a hello and some database descriptor packets. That's your first instinct that it's a MTU mismatch and that we need to figure out what's going on with it. So let's go back into it and let's clear it. No IP MTU. We'll reset it, and then as soon as I do that, you should see the neighborship form without a problem. And then we can do show IP OSPF neighbor detail. State is full. There's no DR or BDR because, again, this is a point-to-point link. And if we look at the routing table, we will see that we still have that same route. And we can ping it, and everything is good. The next issue that is commonly seen in OSPF is the timers have to be the same. So by default, the OSPF timers are set to a hello interval of 10 and a dead timer of 40. So the hello is always the dead is always 4 times the hello. So let's go into the Juniper now, and let's modify the hello interval to be 1 and the dead interval to be 4. We'll reset the neighbor adjacency, and we will see what happens there. So we have a bunch of hello packets, so we know everything is good. And let's see where this gets us. We're going to go into configure mode, set protocols OSPF, area 0000, interface GE000. We're going to do a hello interval of 1, and then we're going to do a dead interval of 4. We're going to commit it, and then we're going to clear OSPF neighbor all. Now, if we look on the router 1 side, there we go. Took a minute. Whenever you clear on one side, it always takes a minute for the other side to go, oh, I have to clear. So now you don't even see neighbors. It's not stuck in two-way. It's not stuck in anything. You just don't see any neighbor on router 1. What does it look like on router 2? Show OSPF neighbor, nothing. What does the packet capture look like? The packet capture is just a bunch of hellos. And in those hellos is where it's sending its timers, which you can't see it in the packet capture, but it's going, hey, my timer is, whatever. And there you go. Hello interval is 1 second from router 2. If you look at router 1, his hello interval is 10 seconds. So there's a mismatch there. So this neighborship will never form. It won't even get past the hello stage. It's not even recognizing who's on the other side. So if we go into configure mode and let's do some trickery. So we're going to do delete protocols OSPF dead interval 4 hello interval of 1. If you want to see in Juniper the pending config changes before you hit commit, you can do show compare. And it's going to show you exactly what it's removing. So it's going to remove a hello interval of 1 and a dead interval of 4, and it's going to take it back to the default. And it's not going to show you the default because it is the default. We can commit this. We can exit. We see instantly the neighborship comes up. If we look at our packet capture, we're going through our database description, our requests, our updates, and our acknowledgements, and some more hello packets. And if we wanted to check it again, everything is good, and we're up, and we have a fully functioning small OSPF network. OSPF neighborships aren't magic. They're a handshake with rules, and things like MTU mismatches and timer drift are how you quietly break production networks. I don't like that. I'm going to do it again. OSPF neighborships aren't magic. They're a handshake with rules, and things like MTU mismatch. OSPF neighborships aren't magic. They're a handshake with rules, and things like MTU mismatches and timer drift are how you quietly break production networks. This is the difference between memorizing OSPF states and actually understanding why adjacencies fail. Now that you know how neighborships form and how they break, in the next video, we'll scale up to multi-area OSPF and start tackling real network design. If this video helped and you think beyond the exam, don't forget to smash that like button and subscribe and drop the messiest OSPF problem you've ever... Now that you know how neighborships form and how they break, in the next video, we scale up into multi-area OSPF and start talking real network design. If this video helped you and now that you know how neighborships form and how they break, in the next video, we scale up into multi-area OSPF and start talking real network design. If this video helped you think beyond the exam, don't forget to smash that like button and subscribe, and drop the messiest OSPF problem you've ever inherited in the comments below. I'll see you on the next one.